Also hello from my side. Hopefully all of you know me until now, otherwise you have missed too many courses. So who doesn't know me yet, my name is Carsten Tellmann. I work for G-Data, that's an antivirus company located here in Bochum, and we are offering an additional evening event. Every time we have an invited speaker here, but as Markus already mentioned, this is the last course and the last invited speaker for this term. So hopefully all of you had a good start into the new year and all of you are very motivated for the final phase of the course. For the event, basically there you can see some facts. We will go over to my company after the talk and then we have a nice dinner, cozy atmosphere, some drinks and hopefully nice discussions. So if you're interested in joining us, talking to the speaker a little bit more in detail about the topics he's presenting today, or if you want to talk to people from the more technical part of the antivirus industry, all of you are welcome. You can come to me after the talk if you need more details. And yeah, for me today it's also quite special because Joern is not only an old fellow from the IT security studies here, but he is also one of the founders of the local hackerspace called Labor. And I'm really happy to have him here, and I guess he will present some interesting stuff today. So please, let's welcome our speaker, Joern.
Thanks. Hi. Well, yeah, I already got like almost completely introduced. My name is Joern. I go by the handle of Joernchen in some places in the internet. I studied ITS a while here and did not bother to graduate. That's one thing you shouldn't do like I did, maybe not, I don't know. It didn't harm me too much, but yeah. So since I decided to not study anymore, I work as a security consultant at Recurity labs in Berlin. And basically what I do on a weekly basis, maybe 2 weeks, maybe 3 weeks, mostly on a weekly basis, some client comes to us and says, hey, we got this product, it's either self-developed or bought, and they want to assess the security of this product. So we define a scope, and then everything in scope will be analyzed in terms of security. That might be source code, that might be a design review, whatever the task is. Then we typically write a report about our findings and give recommendations, and then the next project starts. So you see a lot of scary, amusing, and funny stuff while doing security consulting that way. So within this talk, I'll go first with a non-agenda, what's not going to be covered. All those points like Google dorking, phishing, brute forcing, having weak configurations, insecure defaults, or doing social engineering are completely legit ways to break into stuff or to hack somebody. But instead, I will focus on bugs you can see in source code, because that's like my main interest. I really enjoy reading source code, so I want to show you a bit the approach of finding bugs and how to spot them. And I'll rant a little bit about some things after that. So high-level approach on reading source code with the aim to find security vulnerabilities. First of all, think about every line and think about potential like side effects, unwanted effects that line of code could have on maybe itself or other lines. Read the fantastic manuals and documentation, because the developers mostly don't do it, and there is like mostly the root code. They wanted to do X and use function something, but function something also does Y, and they didn't think about Y, so we can take advantage of Y. What's also very important, especially when you come to the point where you combine vulnerabilities into something which has then most likely more impact the environment and the context of a piece of software, where it's used, how it's used, maybe even compiler flags are important for you in terms of exploitation or exploitability. And what really helps me if I read something like a function or a method, and I got a strange gut feeling, and I think, that does not look too good, but I would not know by now. Well, I read something else and read it again later. Just do it over and over, because yeah, after a while you will get a feeling for this looks good, this looks not so good, and this is complete bullshit. So practice a lot if you're into like reading code. There are some like generic things which should like raise your there might be a bug flag immediately. So yeah, I guess crypto is quite well understood or well taught here, so I don't have to elaborate too much on this. But also what instantly hurts me a lot is when I see int len, because what is even a negative length? If it's unsigned, it's okay, but a signed length is always causing lots of headaches when I read this, and it might lead to interesting integer issues in C code. Also, not checking return values of functions you call. Yeah, it's not the smartest thing if a function gives you a return value which says I've worked or I've not worked, and you don't even bother to check it. Well, then that's another good indicator for there could be something which the developer had not in mind. So yeah. And the obvious root of all evil is user input in any form. Everything I, as a user or attacker, can influence within the program has to be treated a bit more special or careful by the developer. So we'll come to some examples later. But yeah, that's just a random set of things which you would have in mind when you read some code and want to spot some issues. So actually there's a thing called Linus law, and yeah, it's given enough eyeballs, all bugs are shallow. Problem I have with this, we have like, speaking only of security bugs, we have a limited set of eyeballs, being people who audit source code, but we have a much more greater set of people writing code. So it's a lot of eyeballs against lots of, or even more developers producing more and more code. So that's good because, well, it's job security for me. And it's fun. So you can like go to GitHub or Bitbucket and grab a random project and read it, and maybe you're lucky. So one pretty common thing, I guess everybody gets what the issue here. That's a pretty boring SQL injection in PHP. For those who've never seen a SQL injection, so we got user input here, which is a plain get parameter, and this will be put into a SQL query, and then this query would be executed. So we can put fragments or even arbitrary SQL statements in our user input, and by that, yeah, modify the query in a way of our benefit. So something completely different, but also a well-known type of vulnerability. That was so the code before was just some example of how to not do it, so it was not actual production code, but that was sudo. You all might know if you use some kind of Unix. It used to have a debug method, and this worked like you give it a log level and a format and some var args to put out a method. And the problem was here it would get its own program name, so sudo in that case usually, and then fill it in this string and then use the made up string with the program name as a format string here. Yeah, problem being if sudo is suddenly called %s, %x, %n, and if you find a decent combination of those characters, you could write arbitrary memory by a format string issue, obviously. So point being here, both bug types like SQL injection and format string issues are known since at least 2000. So it's really annoying to have when this sudo bug was found in 2012 or disclosed in 2012, and 12 years after a well-known bug class, you have such issues even in security software, which is widely used. So that's annoying. But yet again, that's job security. And yeah, the big advantage or problem we have, depending on from which side you see it, people do the same mistakes over and over again. If they code their first PHP web app with a database backend, they will most likely implement SQL injection in the one or other way, unless they got like properly educated, which mostly seems not to be the case. So this one, another nice example. I don't know if anybody, I obfuscated it a bit to like the variable names and the constant names to not make it too obvious where this is from. It's pretty easy. We take a packet which is user given, and then we have a length here, and actually all we want to do here is something like an echo. So we get the packet, parse out if it's this request we want to answer to, and just want to answer back what's been sent to us, and what's been sent to us comes with a length. And then we allocate as much buffer as we need for what's been sent to us, and then copy it back, and then send it out. Anybody recognize this vulnerability? That's Heartbleed, exactly. So I was when Heartbleed came out and the patch was in the repo of OpenSSL, I looked at the diff, and I was shocked because it was like, dude, I could have spotted this. Seriously, I could have found this. Why didn't I ever look at OpenSSL? So yeah, so even OpenSSL, like, we just had the fallout in terms of a shitload of CVEs which were all low critical, but which was already questioned. But so people, I guess, have woken up a bit with respect to OpenSSL and started auditing it. And now that's the fallout in the beginning of this year, what came out in terms of disclosures. So main takeaway, don't fear a project, or don't fear to assess or read or audit a project which is well known and established just because it's well known and established. This is just, I guess, yeah, it has been found independently by two parties. So one was Neometa from Google, and the other was some guys from Codenomicon, which made all the media hype, and they claimed at least they found it automated. So, I mean, the pattern is pretty clear. You take a length out of the packet, and then you say, hey, oh yeah, you sent me 2 kilobytes. Okay, I answer you with 2 kilobytes. That's what you sent me, but that was just 4 bytes. Well, yeah. Funny enough, so those pieces I just showed are pretty much, I just made up this term of self-contained issues while producing the slide set. So the thing I want to point out is like those are things you find when you look at it and you think about it within the code itself. Those bugs are sometimes a bit more easy to spot and should be a bit more easy to fix. But you can have like more complex stuff. I won't put the source code of this bug here because it's way too complex. But it was pretty simple. So Kincope found in 2009 a FreeBSD local root exploit, which was exploitable by the ping command or any other setuid command, because the loader on FreeBSD should remove on SUID binaries, it should remove dangerous environment variables like LD preload. But as long as you had a malformed variable within your environment, the unset-env call within the loader would then say, oh, here's a malformed variable, I'll bail out now. So your LD preload makes it through to the setuid binary. And with that, you can just say, hey, use this library I compiled just over there, and that usually drops you into a root shell. So if you're interested, there are, I guess, at least 2 or 3 write-ups on that issue. Wonderful, a really beautiful bug. So in order to keep your eyeball sharp on spotting bugs in source code, yeah, I love open source in terms of, well, that's great. I can just download whatever and look at it, and they won't charge me anything for just enjoying reading their source code. Wonderful. So you just go to GitHub or SourceForge if you're brave, or Bitbucket, or wherever the software of your interest is hosted. You can download it. You can deploy a test setup, and then start reading it. And the good thing, if you have a test setup, you can actually verify if that what you thought might be an issue actually is an issue. So it's pretty simple and cheap, actually for free. So another example. This is Ruby code. I have a certain fetish for Ruby, but yeah, some of you might know. This is user-given. This is partially user-given. We can at least make ref being not set, so ref will be head. It's done perfectly fine here. That will call popen, but with the arguments being passed as an array, so we can't inject like something. So we can't do plain shell command injection, like having a query of lala semicolon rf/ that won't work. So at first this looks fine, but then if you think about it twice and read the fine manual of git grep, you will find the great command line option of -o which is open files in pager, and then you can issue an arbitrary command as a pager. So if we think about it again, yes, okay, we can do that. We can inject arguments to this popen call on the shell, so we can tell instead of having in our search query something and then a meta character which won't get parsed, we just do -o rmrf/, and then this would still be valid because the ref then would be the actual search term, and if we can manage to have in that repo which will be grabbed the word head, it would match, and the pager, which is our rm call, would get executed. Well, yeah, that was a fun little bug I found in some Git-based web wiki not so long ago. It almost worked on GitWeb, but it didn't. I'll explain a little bit more when the camera is off. That one looks like a pretty shady way to generate password reset tokens. That's PHP. And the idea was, this is a random thing, this is a username, and the SHA-1 of it should be fine enough. Okay, I guess some of you here are good at PHP. What is admin plus what's the result of this calculation, of this expression? So we want to reset the password of admin and want to get his token. And let's say unique ID would give us that, and the username would be admin. What's the result of this calculation, of this expression?
Appended?
No. Funny enough, this yields 4. Because PHP, smart as it is, thinks, oh, you want to do plus, so plus is done on numbers, so I'll cast this to a number. And this obviously is a 4, so the result is 4, so SHA-1 of 4. Then for the SHA-1 operation, it's cast back to a string. Sure. SHA-1 of 4 was the result because unique ID is time-based, and the timestamp starts at least with a timestamp, and the timestamp back when this bug came out always started with a 4 something, 4F, I guess. So eventually this would turn into 5 or even 50. But yeah. Ridiculously broken by accident. I guess in PHP, I'm not the best PHP coder. I'm actually not a good coder at all. Maybe they wanted to do this or something like for concatenation. But if you add strings and strings, you get numbers which might correspond to something else you thought of. Just a recent issue found by Joshua Drake on ASUS routers. I don't know if anyone has heard of this thing. So he found a remote command execution via UDP packet sent to broadcast, and at least they tried to validate the MAC where it came from. I guess the author of this check has an IDE which does autocompletion on memc, and then he says, oh, memc, yeah, right, that's the function I want to use. Actually, this should be memcompare memcmp instead of memcopy. So that's So if you want to see something similar, like maybe a cut and paste fail, something like a cut and paste fail, you should read up on the go to fail vulnerability in iOS. It was equivalently funny. But yeah, sometimes you just sit there and look at this, and then your eyes start bleeding if you see such stuff, and or if you're not as evil person, maybe you feel for the developer and his pain. Yeah. So one of my favorite bug types. So let's assume here that this token is properly generated. It's a sufficiently long string of some hex value. Okay. That would be fine with any database backend except MySQL, because MySQL does almost the same as PHP. So if you compare numbers to numbers, that's fine. If you compare numbers to strings, it starts getting weird. And it is weird because it basically does the same like PHP did here. So we can if we can put in a number here, Rails would then propagate this number instead of a string to the MySQL database and return a user. So and the good thing for us, like from an attacker's perspective, is that we can type values in our user input. For instance, with if we post JSON, so we send a user token of the array of the numbers instead of strings 0 to 9, and we get a random user's password reset. And then we do it again, and we get another user's password reset, which is a fun sport, like playing account roulette on some web apps. Well, yeah. So that's like another showcase how things blow up in sometimes really unexpected ways. And finding this attack vector was really quite entertaining. So practice. If you want to like make it a hobby or a profession to read source code, find bugs, and or make fun of developers or feel with them, depending on your mindset, you need practice. And practice should maybe, if you've never done this at a larger scale, you should start off with some low-hanging fruits, like I don't know, your sister's boyfriend or your brother's girlfriend has developed a web application with a database backend. You might want to read on this first. If you're brave and well experienced already, you might just want to read OpenSSL. You shouldn't be too focused on one language, because if you do it like in security consulting, you get the 1 week you get Java, then you get C, then you get PHP, and suddenly there is C# and whatnot. So knowledge, I mean, it's okay as long as it don't get into functional languages. It's the same-ish at least. So and you always should like keep the environment, and that meaning not only the environment variables in a Linux or Windows system, but the whole thing where it's used and how it's used in mind, because the way how and where it's used might influence how and where you can exploit it or will exploit it. Also combination, so some low severity plus some low severity might be critical if combined well. If you want to try it at home, like as I said, get your favorite open source project, use the source, Here's some war games you could play. The Natus war game is especially nice for that part I want to transport here, because it's a web application war game written in PHP, and you see for each level you see the source code. So then you can figure how to exploit from its level based from level 1 to I guess 26 or whatever the highest level is. That's a little Ruby on Rails challenge I wrote once, which is still online. You could try out if you want to. So after all this source code, more a little rant. So why is software so vulnerable? I don't know, but what can we do about it? You don't want malware, you use AV. You don't want to get owned by ODE, by our IPS. 100% ODE free, proof even. You got owned? Oh, yeah, that was an APT, maybe from Korea or China, I don't know, but for sure it was an APT. I redefined this acronyms a bit. So, okay, I install AV. It gives me additional vulnerabilities within itself. Yeah, because it has to parse a lot, and parsers are the things which tend to break first. It takes apart every known file format and wants to look into everything and tries to go at this offset. Oh, this is a wrong memory page. Okay. And IPS, of course, is increased parsing surface, because you once again process packets and look at them and try to tear them apart and see if they are dangerous or not. APT, sure, let's blame someone else, someone mightier than us. APT is ancient programming techniques. I got a proof for that on the next slide, but on the additional vulnerabilities, there are at least those 3 papers where the first one is pretty recent on vulnerabilities within antivirus products. So yeah, might save you from some drive-by downloads, but if Tevis O targets you and you use Sophos, bad luck. No, I just want to point out here, adding more and more software on broken software does not necessarily repair the broken software. There are really lots of things you can do different and better. But ancient programming techniques, so that was pretty recent blog post from some, I don't even know what this company does, but they blogged about Trula, one of the most complex APTs in the world. And they elaborate how complex and advanced and threat and persistent it is. And then they say the sample is a stealth backdoor based on the CDOR sources. Who has heard of CDOR before? One? CDOR dates back, like last time touched in the year 2000. That might be a reason why you never heard of it. It's a ancient programming technique, but it's the most complex and advanced and persistent thing you can think of. So it's easy to blame some shady whatever APT thing if you got owned, and yeah, you might want to blame someone who is not you or your admin, so you blame some mighty APT thingy. Yeah, I don't get it. Okay, that was my little rant. I hope I didn't rant too badly. I guess it was okay. I didn't swear at all, right? Any questions? Thank you for your time.
Young again.